Welcome back. We are in lesson 17 and we're going to start today with 17a, talking about factors and coefficients, and then we'll talk about some terms, and then we'll talk about the distributive property, which is where algebra really starts to get fun. Yeah, I said algebra is fun. It's okay. So let's begin. If the form in which variables and constants are written, meaning this right here, if we understand that this format means that this is multiplied by this, then we say the expression is an indicated product. Okay. And of that, this whole thing is a term. So this is a term. We've talked about that before. We call this a term. Now within this term, we have a constant, right? And then this one is the variable, right? We've talked about that before. But to each other, they have a relationship, and that relationship to each other is coefficient. Keyword, that's supposed to be a T and a okay, it's just a T. There we go. I can't spell tonight. Sorry about that. F-I-C-I-E-N-T. Okay. They're coefficients to each other, right? That's what that means. So 4 is a coefficient to x, and x is a coefficient to 4. The root word, the key word, or the prefix is co. And efficient is from the word efficiency. So they depend on each other, right? They're coefficient. In order to get the expression that or the indicated product that we're looking for, they have to depend on one another. So they're coefficients to each other, even though they each have their own name as well. That's not super important, except when you're talking to somebody else or you want to ask a question in math class. It's good to know what to call it so that you can ask the question well, and then I can help you faster because I understand what you're talking about. Okay. If the coefficient is a number, like the number 4, we call it a numerical coefficient. And if the coefficient consists entirely of letters or variables, we call it a literal coefficient. So you have a numerical coefficient, and that's the number or the constant, right? And then you have the literal, which is the letter or the variable. Okay, and sometimes that variable could be pi. So it's not necessarily always a letter, but that's what you want to think about it as. So a term, like we said, is just the combination. It's the whole thing that's put together. A term is thought of as a single entity that represents or has the value of one particular number. So this has one particular value. We just don't know exactly what that is because it has a variable. Because we know they're multiplied times each other, they're going to have a product, and that product is the value that we're thinking about when we look at this term. Okay? All right, so you're going to want to jot all that down, as much of it as you can read. I know my handwriting is a little spastic. I changed the tip out on my pen, and it still seems to jump around a little bit. So I'm not sure what that is. So anyway, take those notes, and I'm going to clear this page. And 3, 2, 1. All right, so let's move on to the distributive property. So we know what the commutative property is. The commutative property comes from the root word commute, which means to move. And the commutative property for addition and multiplication both say that it doesn't matter which order you put those numbers in. You're going to get the same result if you add all of these numbers together regardless. Like, so if we have positive 2 and negative 3, it doesn't matter what order we put them in, we're still going to get negative 1. If we did negative 3, positive 2, combine those two numbers, we're still going to get negative 1. Doesn't matter. That's the commutative property of addition. Well, the commutative property of multiplication says that if we multiply 3 times, I meant to make it 2, times 2, we get 6. And if we multiply 2 times 3, we get 6, right? So that's the commutative property of addition, and the commutative property of multiplication. Again, it comes from the root word commute, which means to move or to travel. Now we're going to talk about the distributive property. I want you to look at that word for a moment. Distributive. When you think about the word distributive, you see there's a root word in here, to distribute. Distribute, or distribute, depending on whether you're from the north or south, means to hand out or pass out, to give things out. Like we could say that the rain was distributed on the ground or on the earth. But it means something a little bit more in math. It means to distribute evenly. That's the key thing here, is that it has to be spread evenly to what it is associated with. And I'll give you a little distributive property illustration here. If we have 5 minus 3, what we typically would do with this is we would solve and say 5 minus 3 is 2, and then 4 minus 2 is 8, right? That's what we would get as our answer doing it this way. Well, sometimes we have variables in here, so we can't exactly do all this math, and so we have to distribute what we can do to get some type of answer. Let me show you that it would be the same answer when we distribute versus when we just solve. So I'm going to distribute, and the way to distribute is you take this number and you apply it to both of these. You multiply it equally to both of the things or all of the things inside the parentheses. It's kind of like a little rainbow. First you go to this one and multiply, and then you go to this one and multiply, and you keep the sign of the number with that number. So 4 times 5 would be 20, and 4 times 3, or 4 times negative 3, would be negative 12. Now, 20 minus 12 is 8. Same answer regardless of how we did it, which gives you insight into understanding that the distributive property is indeed a valid method of solving a problem. When you can do it this way and this way, regardless of the problem, and get the same answer, you know that both ways are valid. And so distributive property works. We've proven it. Now, there are going to be a couple of times where you're asked to illustrate the distributive property with letters A, B, and C. And you are going to need to write this down in your notebook, in your back cover. And this is the distributive property. And you can just write down distributive property, or dist-prop, A times B plus C equals AB plus AC. And all that says is A times B plus C, right? That's what we had here, A and B and C, is the same thing as A times B plus A times C. So it applies to both of the things on the inside. And that's how it's distributed. A is distributed to both B and C equally as a factor. So this is something you need to write down, because you are going to have this as a question in your homework and on tests in the future, and probably until the end of the year. This is one of those things that you need to be able to pull from your memory and write down and spill out. This is how the distributive property works. All right, I've spent too much time on that. Let's do some example problems. I'm going to clear the page. No, I'm not. I'm going to use a space right here. Let's do 17.1 right here. It's not very big. So we are going to use the distributive property to find the value of 4 times 6 minus 2 plus 5 minus 7. And we have to use the distributive property. We're not going to add all these together. We're going to distribute. So 4 times 6 is 24. 4 times negative 2 is negative 8. 4 times positive 5 is a positive 20. And 4 times negative 7 is negative 28. Now we solve, and we get, we get positive 20 and a positive 24. That's going to be 44. And we have a negative 8. So 44 minus 8 minus a 28 leaves us with 8, right? Let's double check that. 24 minus 8, that's going to be 16 plus 20. That's going to be 36. Yep, that's 8. There we go. All right, sorry about that. I got sidetracked. I was reading something in the book. But yes, that gives us 24 minus 8 plus 20 minus 28 gives us 8. So this gives us 16, this gives us 36, and this gives us 8. All right, let's clear the page. You should have all of this written down. If not, pause and then proceed. 17.2, we only have 4 problems, by the way. So 17.2, I'm going to try to do them all on this page. We're going to use the distributive property to expand, and we have variables this time. I'm excited. I love to use variables. They're so, I don't know, exciting, and you never know what you're going to get. So we're going to expand this, and we're going to use the distributive property. You can see what I mean by you can't solve this. So all you can do is distribute and try to get something similar, or get something that you can combine later. So mn times x, we'll do the rainbow to this one, and then to this one, and then to this one. So mn times x is m n x, because it's literally m times n times x. Now we have a positive y, so m n, and we write our y. Now when we do it times a whole number, you always put the whole number first, so it's 2, and then m n p. And there's a reason why I write them in in alphabetical order, and you'll find that out later on. This is as far as you can go. This is your answer. Okay? So it doesn't have to be complicated to be accurate. Sometimes we think there's a lot of steps we need to take, but that's not the case. We're just distributing. We're just making sure that it's equally distributed to all parts. All right, 17.3. We have parenthesis first this time. X minus 3y plus xz. All of these terms are different, so that's going to tell us all of our results are going to be different. And this is times MP. So this time we're just going to work backwards. We're going to start with the first one, but we're going to multiply from behind. That's what I mean by work backwards. So MP times X is MPX. MP times negative 3Y is negative 3MPY. And MP times XZ is going to be MPXZ. That's all we can do. All right, 17.4. I'm going to let you guys do this one. It is pretty straightforward. We have negative 3 times 2x minus 4. So see what you get. Pause the video, solve this problem, come back and see if you got the same thing I did. All right, so this one was pretty easy too. So I said negative 3 times the first term, which was 2x. Negative 3 times the 2 is going to give us negative 6, and we don't know what x is, so we just bring that factor down, that coefficient, and it's negative 6x. That's all we can do. So now we look at the second term. Negative 3 times the second term of negative 4 is going to give us a positive 12. So we write down positive 12. That's all we can do. That's the answer. So if you got negative 6x plus 12, good job. You get a smiley face. That's all we have for lesson 17. Not a whole lot of example problems. But the main thing that you need to remember are the terms we learned in the first part and the distributive property. Don't forget that distributive A times B minus B plus C equals AC plus BC, or AB plus AC. Remember to go back, write that down if you didn't, and memorize. That is your illustration of the distributive property, and that's going to help you in the future. All right, that's all I have for 17. I'll see you in 18.